The legendary B-2 Spirit stealth bomber has returned with groundbreaking upgrades that push the limits of military technology. Once a Cold War secret, it's now been transformed into a weapon that feels decades ahead of its time. From hypersonic readiness to futuristic invisibility, this aircraft has left rival nations scrambling to catch up. Why are experts calling it the most advanced bomber in history? And what does its rebirth mean for the future of global defense? Join us as we uncover the secrets behind the upgraded B-2 Spirit. The B-2 Spirit stealth bomber has just received a round of upgrades that defense analysts describe as almost unbelievable for an aircraft that first flew more than 3 decades ago. What was once a Cold War marvel has now been reshaped into something that feels designed for the next generation of warfare. At the heart of this modernization effort is a system called Spirit Realm 1, or SR1. With this open mission system setup, the bomber can take on new weapons and functions through simple software updates instead of requiring costly hardware changes. Thanks to this framework, the Air Force can integrate advanced munitions, such as the GBU-72 bunker buster, and may even prepare the platform to carry hypersonic missiles, all without dismantling the aircraft. Engineers took a very different approach with this upgrade. By adopting what they refer to as a software factory model, teams are now able to design, test, and roll out new features at a speed that would have been unimaginable in the past. This method reduces defects, speeds up development, and ensures that the new features work seamlessly alongside the B-2's existing avionics. The cockpit has been updated as well. Pilots now work with improved displays that provide real-time battlefield information, helping them plan missions more efficiently and react faster while in the air. Communication systems have been modernized as well, replacing the old single-channel setup with a system that supports simultaneous voice and data transmission. One of the most critical improvements came from advances in satellite communications. Through beyond line-of-sight connectivity, crews are now able to get real-time updates on targets and shifting mission requirements, even when operating deep inside contested airspace. This level of in-flight adaptability greatly improves overall mission flexibility. At the same time, stealth remains the B-2's defining advantage, and engineers have continued working to make it even more effective. A specialized survivability team has introduced both hardware and software enhancements to sharpen the bomber's radar cross-section signature. These tools give pilots the ability to detect, locate, and classify enemy air defense systems while still preserving their low visibility profile. This round of changes builds on earlier efforts under the Defensive Management System Modernization Program, which upgraded the aircraft's electronic warfare suite. The B-2 can now detect and classify threats while also gathering valuable electronic intelligence, all while remaining cloaked from radar. The timing of these developments is no accident. Both Russia and China have spent years designing advanced radar networks and missile systems specifically aimed at countering stealth technology. Keeping the B-2 ahead of those capabilities is vital, especially since the aircraft continues to serve as America's only long-range penetrating strike bomber. Today, just 19 B-2s remain in service after the loss of 2 aircraft in earlier incidents. Each one undergoes a full overhaul roughly every 9 years, which includes structural maintenance and the reapplication of radar-absorbing coatings. Because the fleet is so small, extending the life and relevance of each aircraft is considered essential for maintaining the United States' ability to strike targets anywhere in the world. The B-2 can deliver up to 40,000 pounds of conventional or nuclear weapons and, with aerial refueling, can reach intercontinental targets without detection. Until the new B-21 Raider enters service later this decade, the Spirit remains the backbone of America's deep strike capability. The Spirit Realm 1 program makes sure the bomber doesn't fall behind. By relying on continuous software upgrades rather than major redesigns, the Air Force can keep the B-2 responsive to evolving technologies and threats. Defense officials believe these changes will keep the bomber viable well into the 20s. The flying wing design that once looked decades ahead of its time has now been adapted again, proving that a concept born in the 1980s can still set the standard for next-generation aviation. The most expensive military aircraft ever built has now advanced to a point where it seems to defy the very rules of radar detection. How can a machine larger than half a football field disappear from the most sophisticated surveillance systems in the world? The B-2 Spirit achieves a kind of invisibility that once seemed impossible. Radar operators facing the aircraft often find their screens showing nothing but empty sky. Despite being 69 feet long with a wingspan of 100 to 72 feet, the bomber can appear no larger than a small bird on advanced detection equipment. The foundation of this ability lies in its design. Unlike older bombers that rely on vertical fins and sharp edges, the B-2 was designed as a seamless flying wing. The design of the aircraft forces radar signals to scatter in multiple directions instead of bouncing straight back to enemy stations, which makes the bomber much harder to track. Equally important is the special coating that covers the entire surface. This material absorbs those signals and disperses the energy as heat rather than sending it back to detection systems. Maintaining that protective layer is a constant challenge. Each bomber must be kept in climate-controlled hangars, and about every 9 years, the aircraft goes through a major depot cycle where technicians carefully strip and reapply the coating to preserve its stealth. The process costs millions of dollars per aircraft, but without it, the B-2 would quickly lose the low visibility that makes it so valuable. Even the engines were designed with stealth in mind. 4 General Electric F118 engines sit hidden within the wing itself. The air intakes use curved ducts that block radar waves from reaching the turbine blades, which would otherwise light up on detection systems. Exhaust nozzles mix hot gases with cooler outside air to cut down on heat emissions, lowering the aircraft's infrared signature. Heat-absorbing tiles, similar to those once used on the space shuttle, line critical areas of the bomber. These prevent heat tracking systems from locking onto the B-2 even when it operates at altitudes above 50,000 feet. Another remarkable feature is its contrail management system. Most high-altitude aircraft leave long vapor trails that give away their position. The B-2 can suppress contrail formation when necessary, erasing this common giveaway during sensitive missions. Stealth systems come together through what pilots call penetration mode, activated by a button marked PEN. Once engaged, this mode synchronizes all of the bomber's stealth technologies to minimize signatures across radar, infrared, and visual detection. Enemy radar crews often report nothing more than background noise when the B-2 is in this state. The idea of a flying wing is not new. Jack Northrop tested the concept with his YB-49 prototype back in 1947, which had the same wingspan as the modern B-2. Even Germany experimented with a similar design during World War II, building the Horten-Ho 229, but their version lacked the advanced materials and precision engineering that would make the American design truly practical. The science behind the B-2's stealth owes much to Soviet research. In 1962, Russian physicist Pyotr Ufimtsev released groundbreaking research on the way electromagnetic waves interact with different surfaces. His work was meant as pure science, but American engineers later applied those principles to develop the B-2's unique radar-deflecting shape. What began as a theory in a textbook eventually became the foundation for an aircraft designed to slip past Soviet air defenses. The result was the B-2 Spirit, a bomber that blends geometry, radar-absorbing coatings, hidden engines, and thermal management into a single design. Together, these features make it extraordinarily difficult to detect with conventional tracking methods. For air defense crews, the reality is simple. It is nearly impossible to shoot down something you cannot see, hear, or lock onto. Even with all the advanced stealth technology built into the B-2, the aircraft itself is useless without the right person in the cockpit. But what exactly makes someone qualified to fly America's most secret bomber? Since the B-2 Spirit program began, fewer than 300 pilots have ever been trusted to fly it. That number is shockingly small when you consider the size of the United States Air Force. It is often described as the most selective flying group in military history, with acceptance rates so low that even the Navy SEALs seem easier to get into. Getting selected is about much more than raw flying skills. Each candidate goes through psychological testing that digs far deeper than the usual pilot requirements. Military doctors look at personality traits, stress tolerance, and even how well someone can get along with others. Missions can last close to 2 full days, with 2 people locked inside a tight cockpit. The Air Force cannot risk putting 2 pilots together if there's even a chance they might clash or buckle under pressure. Physical skill is just as important. B-2 pilots must have excellent reflexes and steady hands, especially for tasks like refueling in the air, which requires near-perfect precision. The B-2 doesn't fly like any other plane. It has unusual flying wing aerodynamics that demand special handling skills. Learning to control it means starting almost from scratch, even for experienced pilots. On top of that, the security checks are among the strictest in the military. Candidates face background investigations that cover their personal history, family ties, and even their finances. The government wants to be sure that no one flying the B-2 could be blackmailed or bribed into betraying sensitive secrets. Training is another hurdle. Before touching the actual bomber, pilots spend months inside advanced simulators that recreate every system, warning light, and emergency the plane might face. Instructors throw constant challenges at them: engine failures, electrical problems, combat situations, and even extreme weather. Only those who make quick, smart decisions under stress can move forward. Mission commanders receive extra instruction beyond just flying. They are trained in weapons use, navigation, and electronic countermeasures that protect the bomber from enemy defenses. While the pilot focuses on flying, the commander handles the systems. Success depends on both working seamlessly as a team during missions that can stretch almost 2 days without landing. The B-2's cockpit is designed differently from most military aircraft. Instead of sitting one behind the other, both crew members sit side by side in ejection seats. This makes long flights easier to manage because communication is more natural. However, it also forces pilots to adapt to a wider forward view that feels very different compared to other planes. All B-2 flights operate out of one location, Whiteman Air Force Base in Missouri. The base has specially built hangars that control temperature and humidity to protect the bomber's delicate stealth coating. Pilots often spend weeks at a time training or preparing for missions, which means long stretches away from family. Interestingly, most B-2 pilots only fly a handful of missions each year. The bomber fleet is small, and each aircraft is unique. To stay sharp, pilots rotate between different planes so they remain familiar with how each one handles. For many, flying the B-2 represents the peak of their career. Once they retire from the program, they often don't move on to fly other aircraft because of how specialized the training is. Instead, some stay connected to the bomber community by working as instructors or taking contractor roles that support the program. The limited number of trained pilots poses challenges for the Air Force. Whenever the bombers are needed, commanders must carefully balance mission schedules, rest time, and training requirements. Each pilot represents years of investment and cannot be replaced quickly. It is this scarcity, along with the difficulty of the training, that makes the B-2 community one of the most exclusive groups in the entire United States military. These top pilots showed their true skill in missions that are still studied by military experts today. But here's the question: how could just 2 bombers completely change the way wars are fought from the sky? The B-2 bomber made its combat debut over Kosovo in 1999, and it instantly rewrote the rules of air warfare. 2 bombers flew missions that lasted 31 hours straight, leaving from Whiteman Air Force Base in Missouri, striking their targets in the Balkans, and flying back without stopping anywhere in between. Even though the B-2 made up less than 1% of all combat flights during Operation Allied Force, it destroyed nearly 1/3 of the priority targets in just the first 8 weeks of the conflict. Military leaders had never seen anything like this. Normally, hundreds of planes and multiple waves of attacks were needed to get the same results. The B-2 managed to do in one mission what entire groups of aircraft struggled to accomplish. The bomber named Spirit of America set a record during Operation Enduring Freedom in 2001. It flew the longest combat mission in history, 44 hours non-stop from Missouri to Afghanistan and back. The engines never even shut down during a quick 45-minute crew change, after which the aircraft immediately launched again for another 30-hour flight. In total, it stayed in continuous operation for more than 70 hours. Each B-2 carried up to 40,000 pounds of guided bombs and smart weapons on these missions. These weapons were so accurate that commanders on the ground reported that the B-2 was able to hit high-value targets that other aircraft couldn't touch. Because the missions were so long, refueling in the air was essential. Every 6 hours or so, A KC-135 tanker would meet the bomber high above enemy territory to transfer fuel. Both aircraft had to fly in perfect sync for the transfer to work, making it one of the most delicate parts of the mission. The B-2 quickly became the aircraft trusted to strike first. It opened operations in Iraq, Afghanistan, and Libya by slipping into heavily defended airspace that other aircraft couldn't enter safely. Once the B-2 had destroyed key defenses, other planes could follow. Today, this first strike role is standard military practice. What made the B-2 so valuable was its ability to hit any target in the world within hours of being ordered. It didn't need bases in other countries or staging areas closer to the fight. It could launch straight from the United States and still complete its mission. Its advanced navigation systems meant it could fly and strike accurately in any conditions. Using radar and GPS-guided bombs, it could hit through thick clouds, heavy storms, or complete darkness. Enemies learned that bad weather could no longer protect them. Each mission proved that the billions spent on stealth technology and long-range strike power had been worth it. The B-2 showed it could achieve major objectives while putting very few aircrew at risk and with minimal civilian casualties. Planning these missions was just as demanding as the flights themselves. Crews spent hours studying maps, enemy defenses, weather, and backup targets before even stepping into the cockpit. Sometimes the planning lasted longer than the actual flight. After the missions, reviews showed the same results again and again. The B-2 hit its targets more effectively than traditional bombing campaigns, while needing far fewer aircraft and weapons to do the job. Despite its remarkable record in combat, America's most advanced bomber faces a serious challenge that could weaken national security. The question is simple but troubling. Why are these rare aircraft disappearing one after another? Back in the Cold War years, the United States planned to build 132 B-2 Spirit bombers. Defense companies prepared for huge orders, expecting that the cost per aircraft would drop once production ramped up. The goal was to create a fleet big enough to eventually take the place of the older B-52 bombers. But history shifted. In 1989, the same year the B-2 took its first flight, the Berlin Wall fell. The Soviet Union collapsed soon after, and with it the need for such a large stealth bomber force. Congress slashed the order from over 100 to just 21 planes. That decision made each B-2 incredibly expensive, more than $2 billion apiece. With so few built, every aircraft became almost like a custom project, each with its quirks and demanding upkeep. Since entering service, the fleet has lost 2 bombers. In 2008, the Spirit of Kansas crashed during takeoff in Guam after faulty sensors caused it to lift its nose too sharply. The crew ejected safely, but the aircraft was destroyed, just like that. America lost 4% of its stealth strike power. Another bomber, the Spirit of Washington, caught fire during maintenance at Whiteman Air Force Base in 2010. Workers accidentally set off a blaze that damaged the bomber's delicate structure and stealth coating. The Air Force debated for years whether fixing it was even possible before finally bringing it back to service. In 2022, another B-2 was badly damaged in a fire and written off completely. That incident left only 19 operational bombers, each one now an irreplaceable part of America's long-range strike force. To keep them flying, every B-2 goes through a deep overhaul about once every 9 years. This isn't routine maintenance, it's a complete rebuild. Workers strip off and reapply the radar-absorbing coating, upgrade the electronics, and replace or repair major systems. Each cycle costs hundreds of millions of dollars and takes months before the plane can return to duty. The aircraft are stored in special climate-controlled hangars at Whiteman Air Force Base in Missouri. The stealth coating is so sensitive that both temperature and humidity must stay within strict limits. If exposed to bad weather or stored incorrectly, the coating can break down, making the bomber easier to spot on radar. Building the B-2 in the first place meant inventing new ways of making things. Northrop Grumman developed advanced composite materials, custom tools, and entirely new assembly techniques just for this program. Once the final bomber rolled out, those production lines were shut down. That means no more B-2s can ever be built with the same methods. Looking ahead, the Air Force plans to keep the B-2 in service until the new B-21 Raider is ready in larger numbers. The Raider is designed with modern materials and updated production techniques, and it also draws on lessons learned from the B-2 program. The first B-21 bombers are expected to be combat-ready later in the decade. For now, though, the B-2 remains the only aircraft that can slip past the world's toughest air defenses and strike anywhere on the globe. Losing even one more reduces America's reach and weakens its ability to respond to threats far from home. Thanks for watching. While you are still here, click on the link on your screen to check out another of our videos. See you there.